Okay, so this is going to be our second example, and we're going to use method of sections for this. We may also go back and review a method of joints just to make sure we're all on the same page. You have to be able to do both. And this time I am told that I need to find KL, CL, and CB. So I kind of have a line drawn, but I can always go back on here and just kind of sketch them in. So I can make sure that they are all going to be taken care of by the same cut, and I can easily see the cut. Okay. If I come from the left, I will have this given 10 kips, but I don't have to worry about my reactions. And I will have these unknown forces. And remember, we assume everything is in tension. So that's kind of like what my free body diagram looks like. If I want to come from the right, I have to include everything, which includes reactions. And that's just one more step that would, I would probably make a math mistake on. So I'm going to try to go with the least amount of steps as possible. If I were to draw it from the right, I can see there are my members that are showing in tension. And when we're looking at this, they're showing in tension. They are equal and opposite, equal and opposite, equal and opposite. So I'm going to draw the right side. I don't really care about this nonsense in here, but I do need to take note of these distances. So let's get this drawn. So I'm going to go over to K, and then I'm pulling up. Okay, so that's force KL. I'm here at H, I'm going to come down to G, and come over to C. Okay, and I can see that I have J and I have D and E and F, and I have 12 feet, 12 feet, 12 feet, 12 feet. I have 16 feet high, and then I have this force pulling towards a dot. The dot up here has got to be right above it, and then I have a force here pulling up towards that same dot. So now when I remove this, these are pulling towards L. So I have force CL and I have force CB. I also know that this distance right here has to be 12 feet. And then this distance, I know that this is 16. I need to go back and find that. So I can look at similar triangles. If this is 26 up, and this is 16 up, then I'm going to rise 10 feet over 2 panels. So that means I'm rising 5 feet per panel. Okay, so if this is 16 and this is 26, this has to be 21. You can also use, if you want to go back and actually use similar triangles, that we could go back and just call this 0. And so I would know that this is 10 feet tall, because 26 minus 16 is 10. And I could look at similar triangles. So if this is 10, and this is 12 and 12, I have 10 is to 24 as whatever that value is to 12. So there's my big triangle, 10 to 24, and my little triangle. Okay, so I do know that that's 21. Which is important because I have to have slopes on these lines in order to complete. Oh, I forgot my 10 kips given. Okay, so if I look at the slope of this, okay, if I look at the slope of this, I go over 12 and up 5. So I go over 12 and up 5. So I know this is a 12, 5, 13 triangle. Okay, this one goes over 12, and up 16 plus 5, so it goes up to 21. And the hypotenuse is going to be 12 squared, 21 squared, plus the square root of 585. So here is my free body diagram. So we can start with, we can sum forces X, we can sum forces Y, and we can sum moments. If I sum forces x, I have 1, 2, 3 unknowns. These both have x components. If I sum forces y, I have 1, 2. These both have y components. So I need to get rid of 2 of these vectors. I can sum the moments about point L. If I sum the moments about point L, both of these go through point L, so they aren't going to cause a moment, which would leave me this unknown force and my given 10 kips. Okay? I could sum moments about C. If I sum moments about C, it gets rid of this unknown, and I have 10 kips. Okay, well, how do I deal with this? Well, looking at this, remember a vector has x components and y components, and it doesn't matter where we look. So I could look right here. There's my y, there's my x. If I sum moments about point C, that y component goes straight through, and the x component will create the moment. So we could solve directly for KL. Where else could I sum moments? That's a great question. I could sum moments here, but I would still have too many unknowns. So let's start with summing moments. Let's start with summing moments about L. Okay, if I sum about L, I get rid of both of these members on the diagonal. They both go through L, and I'm left with this unknown member and my 10 kips. So I have FCB times 16, and it's not times 16, it is times 21, because it is 16 plus 5, so 21. Okay, about L, we're on this line, it is 16 plus 5 up. Now if I look at this 10, I have plus 10, and it is 12, 24, 36, 48, 60. Okay, it is 60 feet over. So I'm going to get FCB times 21 equals negative 600 kip feet. So FCB has to equal negative 600 divided by 21. We get 28.57 kips. So FCB is 28.57 kips. It was negative, so it's in compression. Okay, so you all know me. I like the visual sides of life. So when I think about the math, I'm going to rename this in compression. I'm going to go ahead and erase this. I'm just going to call it 28.57. So now looking at my free body diagram, I still have one unknown, two unknowns. And I could go back. I could sum forces X, I could sum forces Y, and I would end up with a system of equations. I would end up with both of them in the X and the Y equations. And again, the last thing I want to do is math. So I'm going to try to find some place to get rid of the extra unknown member. And that's where if I sum moments about C, okay, I get rid of this, which is known, but it's nice to get rid of forces just because it makes our equations nice and short. I get rid of this unknown, which is perfect, which leaves me KL. Okay, and KL, I don't know that perpendicular distance, nor do I want to do the geometry to calculate it, but I know that KL breaks up into X and Y components. That's how we can find our X and Y equations. And I have that it's a 5, 12, 13. So the X component is 12 over 13 times that force. So when I'm looking at C, if I break it here into X and Y components, the Y component goes straight through C. But I am left with this X component, and it's causing clockwise, which is negative. So I have negative 12 over 13 FKL. Okay, its perpendicular distance from that X component down is 16 feet. Okay, plus 10 times 12, 24, 36, 48 equals 0. So my FKL, we're going to bring it over to make it positive, so it's in tension. And we have 480. And then I have 12 divided by 13 times 16. We have 480 divided by 14.77. And I get 32.5 kips. I got a positive value, so we are indeed in tension. So I can come back up here to my figure and mark it as 32.5 kips in tension. Now I'm only down to one unknown. I could sum forces X and use the X component. I could sum forces Y and use the Y component. I could sum moments about this point, and I could use the X component distance. But I'm going to do it both summing forces X and summing forces Y, because it's only one known, and that way I can check my work. I should get the same answer. So let's start with summing forces X. That's a Y component. Okay, I have a negative 28.57. It's going to the left. It's in compression. I have the X component of this plus 12 over the square root of 585 FCL. Okay, this is in tension, plus the X component is 12 over 13, 32.5 equals 0. And when I solve this out, FCL equals, so let's do our math. We're going to keep this here and move these over, make them negative. So I have 12 thirteenths times 32.5, that's negative. 12 thirteenths, 32.5, negative. And I have a 28.57. It becomes positive as I bring it over. And I'm left with negative 1.43, that now I need to multiply by the square root of 585 and divide by 12. And I get negative 2.88 kips. There we go. Okay. So that would be 2.88 kips in compression. And how can I check that? Let's sum forces in the Y direction. Up is positive. I have a negative 10. This was in tension, plus 5 over 13 times 32.5. Okay, I'm going to assume this in tension, so we have plus 21 over the square root of 585 FCL equals 0. Okay, I'm going to isolate this, bring that over, bring that over. So I have 5 divided by 13, 32.5 times. That becomes negative. I'm going to add that 10 to it. So I have negative 2.5. The square root of 585 times divided by 21. And I get negative FCL equals negative 2.88 kips, which means it's in compression. And so I got the same answer, whether I summed X and whether I summed Y. So I can be pretty confident that I did my work correctly. If I'd gotten two different values, I would need to start going back in and checking my math and checking my free body diagrams and checking my directions. But the beauty of this is in statics is that you should never have a wrong answer, because you can check using another method for equilibrium. You can check your answers.